Electricity is something most of us depend on every day, yet few people stop to think about the technology working behind the scenes to keep the power flowing. Over the years, electrical infrastructure has evolved from simple networks of power lines and transformers into highly intelligent systems that rely on advanced electronics to monitor, control, and improve the delivery of electricity. Throughout this presentation, we'll explore how modern utility infrastructure continues to evolve, why electronic equipment is upgraded even when it still functions, and how thoughtful maintenance, strategic planning, and responsible recycling help reduce electronic waste while supporting a smarter and more sustainable electrical grid. The electrical grid has changed dramatically over the past several decades. Traditional utility systems relied heavily on manual inspections, mechanical controls, and limited communication between field equipment and utility operators. Today, digital technology has transformed nearly every part of the electrical network, allowing utilities to monitor and manage equipment with greater speed and accuracy. Modern smart grids use digital sensors, automated switches, communication gateways, smart meters, and monitoring systems that continuously collect information from across the network. This real-time data allows operators to identify changing conditions, detect developing problems early, and make informed decisions that improve the reliability of electricity delivery. Automation has also reduced the need for many routine manual inspections. Instead of waiting for scheduled maintenance visits, utility providers receive continuous updates about equipment performance and system conditions. This proactive approach allows maintenance to be planned more efficiently while helping prevent unexpected outages. As electrical networks become increasingly connected, electronic technology continues playing a larger role in supporting safe, reliable, and efficient power distribution. Every improvement helps utilities respond more effectively to changing energy demands while preparing the electrical grid for future growth. Unlike many construction projects, electrical infrastructure is not upgraded all at once. Modernization is an ongoing process that takes place over many years as utilities evaluate different parts of the electrical network and determine where improvements will provide the greatest benefit. Before replacing equipment, utility providers carefully review maintenance history, operational performance, communication capabilities, and compatibility with newer technologies. This information helps determine whether existing systems should remain in service or whether updated equipment would improve efficiency, reliability, or long-term performance. Modernization projects may involve installing newer digital monitoring systems, upgrading communication equipment, improving substation automation, replacing aging control devices, or expanding data collection capabilities throughout the electrical grid. These improvements strengthen the network while allowing utilities to adapt to changing technologies and increasing energy demands. By approaching modernization in carefully planned stages, utilities maximize the value of existing equipment while avoiding unnecessary replacements. This measured approach not only supports reliable electrical service, but also helps reduce electronic waste by ensuring equipment is only replaced when doing so provides meaningful operational improvements. One of the biggest misconceptions about utility infrastructure is that equipment is only replaced after it stops working. In reality, many electronic devices continue operating reliably for years, but are upgraded because newer technologies provide meaningful improvements. Modern monitoring systems offer faster communication, greater accuracy, stronger cybersecurity, and better compatibility with today's increasingly advanced electrical networks. As utilities expand renewable energy integration and modernize grid operations, older equipment may no longer support the capabilities needed for future infrastructure. Updated technologies allow operators to collect more detailed information, improve system diagnostics, and respond more quickly to changing operating conditions. These improvements help utilities deliver more reliable service while preparing the grid for future energy demands. Modernization is carefully planned rather than rushed. Utility providers evaluate performance, maintenance history, and long-term operational goals before deciding when replacement is appropriate. This ensures that existing equipment continues providing value for as long as practical, while newer technology is introduced, where it offers the greatest benefit. By replacing equipment strategically instead of prematurely, utilities improve system performance, maximize technology investments, and reduce unnecessary electronic waste throughout the modernization process. Today's electrical infrastructure depends on a large network of electronic devices working together to support reliable power distribution. While power lines and transformers remain essential, they are now supported by sophisticated technologies that continuously monitor and control electrical operations across the grid. Modern installations commonly include smart meters, digital relays, programmable controllers, environmental sensors, communication modules, networking switches, monitoring displays, data loggers, wireless communication equipment, backup power systems, and automated switching devices. Each of these components performs a specific function, but together they create an integrated system that allows utilities to monitor equipment, analyze performance, and respond quickly when adjustments are needed. These electronic systems generate enormous amounts of valuable operational data that help utilities improve maintenance planning, strengthen reliability, and operate more efficiently. The ability to monitor equipment remotely has significantly improved the way electrical infrastructure is managed compared to traditional manual inspection methods. As these technologies continue evolving, many electronic devices will eventually reach the end of their service lives. Recognizing the importance of every component, not just the largest pieces of equipment, helps utilities manage modernization projects more responsibly, while making better use of valuable electronic resources. Every infrastructure modernization project introduces new technology while removing older electronic equipment from service. Depending on the size of the project, this may involve replacing hundreds or even thousands of electronic devices throughout substations, monitoring stations, and other utility facilities. Retired equipment often includes communication hardware, digital monitoring systems, control units, electronic displays, protective relays, networking equipment, and other supporting electronics. Although these devices may no longer meet current operational requirements, they still contain valuable materials such as circuit boards, processors, wiring, and metals that represent significant engineering and manufacturing resources. Viewing retired equipment as valuable electronic assets rather than ordinary waste encourages more responsible management during modernization projects. Proper organization allows utilities to identify reusable components, separate electronic devices from general construction materials, and prepare obsolete equipment for responsible recycling. By recognizing the value contained within retired electronics, utilities can reduce unnecessary waste, conserve important materials, and support a more sustainable approach to infrastructure modernization while continuing to strengthen the electrical grid. Maintaining utility equipment is one of the best ways to extend its service life and reduce electronic waste. Regular inspections help technicians identify loose connections, moisture, worn components, and communication issues before they affect system performance. Cleaning equipment, verifying calibration, and performing software updates also improve reliability and delay unnecessary replacements. Utilities carefully plan upgrades by reviewing maintenance history, operational performance, and compatibility with future technologies. This ensures equipment is only replaced when it provides meaningful improvements to the electrical grid. Supporting electronics such as communication gateways, networking hardware, backup batteries, weather sensors, and remote monitoring terminals are also important parts of the system. Managing both primary equipment and supporting devices together helps utilities make better use of their technology investments, while reducing unnecessary electronic waste throughout the modernization process. Smart grid technology will continue evolving as utilities improve automation, communication, and system reliability. Future monitoring systems are expected to provide faster data processing, stronger cybersecurity, improved diagnostics, and greater support for renewable energy and growing electricity demands. As these technologies are introduced, older electronic equipment will naturally be replaced. Extending equipment life through routine maintenance, planning upgrades carefully, and evaluating opportunities for continued use all help reduce unnecessary electronic waste. Every monitoring device, communication module, controller, and sensor contains valuable materials and engineering. By managing these electronic assets responsibly throughout their life cycle, utilities can continue modernizing the electrical grid while supporting a more efficient and sustainable energy future. Thank you for learning about how smart grid modernization and responsible electronic waste management work together to support reliable electricity. Every infrastructure upgrade is an opportunity to improve performance while conserving valuable electronic resources. Maintaining equipment, planning replacements carefully, and recycling retired electronics through licensed recyclers help reduce waste and support a stronger, more sustainable electrical grid. Reach us by phone, email, or our website. Together, we can build a smarter electrical grid by responsibly managing technology, reducing electronic waste, and protecting valuable resources for the future.